Good evening. The course Data Communication Network. The topic is logical link control. What are the sub-layers of data link layer? Now, the data link layer is divided into two sub-layers. One is LLC and the other one is MAC. One is logical link control layer and the MAC media access control sub-layer. It acts as an LLC acts as an interface between the upper layer and the lower layer and manages flow control and error checking to ensure smooth communication. Media access control handles a direct interaction with the physical layer and manages how devices in a network gain access to the media and transmit data. The functions of LLC facilitates communication between the upper layers and the lower layer, takes network protocol data and add control information to help to deliver packets to their destination, implement flow control to manage data transmission rates and prevent data overflow. Process receives the data from the network layer and ensures it and encapsulates it into frames, adds headers and trailers to the frames to error detection and control. Logical Link Control LLC PDU, that is Protocol Data Unit. Logical Link Control is a sub-layer that generally provides a logic for the data unit, data link, as it controls the synchronization, multiplexing, flow control, even error checking functions of DLL. DLL is divided into two sub-layers, one in LLC and the MAC. We have already said this. Now this is a format for the PDU. DSAP, SSAP, control and information user data, and all these have 8 bits and here 8 or 16 bit, and the data unit is variable. Now we will see each one what it is. Destination service access point 8 bits works like a receiver's address at the network layer. It tells which network layer should get the frame at the receiving side. SSAP, source service access point 8 bits, works like a sender's address at the MAC layer, also indicates whether the PDU is command or response. An information field carries the actual user data from the higher layers, present only in some types of PDU, mainly information PDU. Now, we have already said the PDUs are of different types: information PDU, supervisory PDU and unnumbered PDU. Information PDU carries user data. User data is also called the payloads and also carries sequence numbers for error and flow control. Supervisory data does not carry user data, used only for error and flow control. That is acknowledgement, negative acknowledgement, flow control. Then unnumbered PDU used for control, management and special purposes. Does not always need sequence number to establish. Example, establishing or terminating a connection, exchange special commands like mode setting, etc. Now we will move on to the types of errors. We have 5 types of errors: single bit error, multiple bit error, burst error, lost frame error and duplicate frame. We have said here itself only one bit in a data bit is changed, that is 0 to 1 or 1 to 0. That is called single bit. Multiple bit error is an error type that arises when more than one bit in the data transmission is affected. Now, burst error, 2 or more bits in the data unit is changed. Okay. Then now lost frame never reaches the receiver. Duplicate, same frame is received more than once. So single bit error, we have already said only one bit is changed. That is whatever the data that we are transmitting is 10110001, and here you can see that the fifth bit is changed again to 1. So one bit changed, 10 have changed to 1. So you can see here 1 bit is changed to 0, 0 is changed to 1. Here, high level of noises, high noise levels, electrical interference, this can cause multiple bits to be changed. That is 2 or more bits will change. That is a noisy or faulty network. You can see here 2 bits have been changed here. Now burst error, 2 or more bits in a sequence, and line noise or signal interference. Here several bits have been changed. More common than single bit is a real communication error. So here you can see that many bits have been changed here. That's called a burst error. So here you will be finding that what is the difference between the multiple bit and the burst error. Here the burst error affects consecutive. That is continuously, you can see the continuous 3 bits. And the multiple bit error, here and there one of bit will be changed. That is, affects bits are scattered and not consecutive. Now we have the lost frame. A frame frame fails to reach the receiver, network congestion, buffer overflow, severe transmission error, etc. And here transmits one frame 2, frame 3. Only frame 1 and 3 have reached, frame 2 is lost. So that caused the lost frame. Next one is a duplicated frame. Here a frame is delivered more than once to the receiver. Acknowledgement problem or retransmission errors. That is, sender transmits frame 1, frame 2 and frame 3. Receiver gets frame 1, frame 2 and frame 3. And the receiver must discard the duplicate frame to avoid confusion. So that is only they get multiple errors and they have to discard. They have to see the sequence number and they have to discard the duplicate frame. So today we have seen the LLC functions, the purposes, different types of information bits, then different types of PDUs, then information PDU, supervisory PDU, etc. and the type of errors. Thank you.